everyone, thanks for joining. Very glad you're here. This is a talk about ads on internet, ad blockers, and let's get to the heart of the presentation, a talk about how ad blockers are being bullied to stop protecting user choice. If you feel that this presentation name sounds similar to a movie name, you are right. Catch Me If You Can is the original movie name, and I will stop here because I know that for some of you, even spelling the name of the movie is a spoiler. Sorry for that. So during this talk, we will build a plot for a kick ads movie named Block Me If You Can. But for marketing reasons, we need to start with something very, very simple. A one-liner that, once read, would make everybody understand what's this movie about. And I feel that I found the perfect one. Ready? Blocking ads that block ad blockers blocking them. Easy, right? Come on. Everybody will love it. It's so simple. If you don't agree, go learn some marketing, folks. Come on, it's so good. A little about me. Hi, I'm Alex. I'm a JavaScript developer working with the anti-circumvention team at AdBlock Plus around IO. Okay, so the rise of ad blockers is a new stuff. But what's somehow new is an entire micro-ad industry which knocks at publisher doors, promising to help them reclaim ads revenue from ad blocking users. As a matter of fact, our choice of not seeing ads isn't considered anymore, and we end up seeing ads that are even more intrusive than before. Simply put, the companies use their tech in an attempt to reinject ads into websites visited by an ad blocker users, effectively circumventing the ad blocker. So, starting with this point, it doesn't even matter you deliberately chose not to see ads by installing an ad blocker. No, the circumvention ads will always be there. Why are circumvention ads so bad? Maybe the most important fact is that they are constraining your right to choose what you see. Secondly, these ads won't care about user experience. They will destroy it. They will destroy it by rendering lots of intrusive ads and consuming way more of your machine resources than it should. Simply put, circumvention ads are the bullies of the advertisement industry. Remember, the bully will not kindly ask for your sandwich. He will steal it. Circumvention ads will not kindly ask for your attention. They will steal it. Not only that our choice of not seeing ads isn't considered, but our attention is consumed by ads that are even more intrusive than regular ads. Let's see how ad blockers save the sandwich. We will start by having a look at the basic workflow of a regular ad blocker web extension. At the core of all major ad blockers, we have the filter engine. By giving a filter to the filter engine, we basically tell the extension to block or allow a specific DOM element or a network resource. So, based on the rules found in multiple filter lists, we can filter ads by the rest of the content. You can't have a basic ad blocker understanding without knowing what EasyList is. EasyList is the all-time hero for the filter list. It targets most ads from international web pages and is the primary English filter list available. It was created in spring 2005 by Rick Pednell for the good old ad block. It's community maintained. Filter lists need to be regularly updated, and here is a good place for a big shout out for all the filter authors out there, which are doing their best protecting our right to choose what we see. It's amazing to see such cooperation at this scale. One of the greatest contributors out there is recognized by the nickname of Fanboy. Back in 2013, Fanboy's list merged with EasyList, making him the main author. EasyList has more than 60,000 filter rules and is updated once every 4 days. Now, remember I promised we will have a movie plot? Here we go. EasyList is a little boy that loves his school's playground. On each and every break, he goes outside with his colleagues, his best friend EasyList Germany, and their fellow Romanian Rollist. Every website is a playground. Let's see how EasyList and his friends enjoy the playground. His school playground has 3 main hotspots: the treehouse, the spider web, and the sandbox. Now, remember I said that every website is a playground. The main three areas where EasyList is effective are the DOM tree, the network, and the JS environment. The main two areas where EasyList shines are the DOM tree with element hiding filters and the network with network level filters. At JS level, EasyList doesn't have so much control over the JS environment. But anyway, EasyList and his friends somehow managed to enjoy the entire playground. Everything is nice and fun, they're having a great time. Do you feel that what's missing? Bullies. They want to enjoy the playground too, and they want it all. Let's see the first one, the treehouse. If circumvention ads plan to counter our element hiding filters, they will start messing up with the DOM in such a way that we can't differentiate anymore between ads and real content. Here we can see that every class is randomized. But that's still soft. It gets even worse. Randomized DOM tags. I know, it's insane. What about the spider web? The network is where EasyList takes down most of the ads. Well, one circumventor's approach is to randomize every request for an ad resource. Another approach, and we often see both methods used, is to hide the source of the ads by using proxy servers. Now, let's see the last one, the Sandbox. Here's the place where ads are inserted from. Using JS, circumvention scripts can detect ad blockers' presence. Once detected, the script can choose to blow up the entire website. And if you think that you can easily debug their code, you are wrong. Imagine you have to reverse engineer something inside a file with 30,000 ugly fine lines like that. It's insane. Okay, so the situation sounds desperate. The bullies have taken the entire playground and they won't let EasyList and his friends enjoy any part of it. It's time for EasyList to call his older brother, the anti-civil list. So what makes the anti-civil list or anti-circumvention list to be the big brother? For sure, not the age. EasyList is way older. The anti-civil list was created specifically for countering circumvention ads, and it is used by both AdBlock and AdBlock Plus. Compared to EasyList, which is updated every 4 days, the anti-civil list is updated every 60 minutes. That's a great advantage because now we have more agility on countering ads. But what really makes anti-CV awesome is the support for snippet filters. Snippets, or scriptlets in Block Origin, are JS functions acting as plugins for the ad blocker. They are designed to counter specific circumvention techniques. The most exciting part is that they are plug and play, without the need of architectural changes in the ad blocker source code or design changes in regular filter writing. And never forget security. Snippet filters are secure as we only allow them inside the anti-CV list. Now let's have a short look on a basic snippet filter. Starting from the left, example.com is the domain where we want our snippet to run. Following by what we call a snippet marker, which basically tells the filter engine that what's next to see is a snippet filter. After the marker, we have the function or the snippet name, followed by its parameters separated by white spaces. This snippet filter will run the log snippet on example.com, resulting in console log for hello world. Now that we have the big brother, let's take the playground back. But before we start, let's set up the funny mood. One of our anti-CV filter writers, known by the GitHub ID of Wismark, found something very interesting on one CV website. One of the DOM elements has the ID of Wismark Get Some Sleep. Crazy, I know. We will start with the treehouse. Here we have 3 snippets to tackle circumvention ads with. Let's take a closer look. Hide if matches XPath. This snippet allows us to improve element hiding. Instead of using classical CSS selectors, this snippet accepts the XPath syntax, which is more versatile. One of the reasons why XPath is so powerful is that it allows targeting parent or siblings of a DOM element. Another thing is that XPath allows querying DOM elements by text content. All these predicates can be combined, resulting, unfortunately, in having more complex selectors. Like that. These three XPath snippets are part of the same filter targeting a single website. Ugly, isn't it? For me, XPath is like regex and uglified.js without source maps had a baby. Tada, XPath. But it's powerful indeed. Our next snippet is called hide if shadow contains. Let's say we have the following DOM structure. We can see the ad inside the shadow root, protecting it from outside CSS selectors. So, basic element hiding filters won't help here. But that's why we have hide if shadow contains. This snippet's job is to check all existing shadow roots for matching a particular text, the first parameter. Once found, the snippet will hide the closest DOM parent element matching the CSS selector, which is the second argument. This will result in hiding the div containing the shadow root. Freeze element. I must confess this one is really close to my heart. We observed that most of the circumvention ads are being injected into the page on client side. That's interesting because at the same time, most of the websites targeted by circumvention ads are server-side rendered. So this distinction, having the content being server-side rendered and the ads being client-side rendered, inspired us creating this snippet. Let's have a look at the following DOM structure. Let's say that this first div element, the one with a random class, is the container for the ads. But because this class is randomized and because everything inside this element sub-tree is randomized, we can't properly target the ad with regular element hiding filters. We need something else. What we currently know is that the ad container was inserted on client side. Why shouldn't use that? Freeze element aside. This is a freeze element in action. Once the aside element is frozen, nothing can be added as a direct child of it, so no ads. We can even go further with this and freeze element and freeze the entire subtree of the DOM element. This is useful when the parent element of an ad has a random class too, making us unable to target it. But the grandparent, the element with the class of container, is reachable. Let's freeze it. Love it. Well, enough with the treehouse. Let's take back the sandbox. What we have here are examples of snippets that help us overcome the JS environment. Abort on property read and write. These snippets are so powerful. What they are basically doing is patching a property of the window object, so a global property, in order to abort the execution when that property is read or set. Currently, this is one of our most used tools, used a lot for aborting the execution of circumvention scripts, these scripts that are responsible for inserting ads. And although we have a different implementation, we give credit to uBlock Origin for this wonderful idea. Let's see some action. Let's say this is a circumvention script. On the very first line, we have this global property called ads data being initialized. On line 20, the global property ads data is accessed and passed as an argument to the insert ads function. What happens if I add this snippet filter? Having this filter in place, now, reading or accessing the global property ads data will always result in throwing an error. So, line 20 now throws an error, and as a result, the script execution is aborted. Similar to abort on property read, we have abort on property write, which, guess what, aborts a script execution when a global property is set or written. In this case, the first line. Using these snippets, we can even counter the shadow root technique. The only way to create a shadow root is by using the attached shadow property of the elements class prototype. Knowing that, we can easily avoid that. Now, every piece of code that tries to create a shadow root throws an error. Sweet, right? Well, what happens when it doesn't? It happened to me once for a set of websites. While I was trying to tackle the ads inside the shadow root, I applied these filters and voila, it didn't work. What I discovered next simply amazed me. Let's reproduce this. Here we have the basic way of inserting ads inside the shadow root. We grab the container, attach a shadow to it using the attach shadow function, and then we insert the ad into the shadow. This should be easy to tackle, right? This filter makes the code to throw an error on the 4th line. We saved the day. Well, not really. Let's create an iframe and append it to the body. Well, this is interesting. Each iframe has its own window. We know that. But what I didn't know is that all of the prototype native functions inside this window are entire new objects. So this new attached shadow is untouched by our old filter. Now we can simply use this function to create the shadow in it. Genius. What can we do now? Does the ad blocker have any countermeasure for that? Of course we do. I present you to another long-named snippet. Abort on iframe property read. You didn't see that coming, right? Now we cover not only the global window object, but also the iframes Windows objects. We are getting better. Another one, JSON prune. This one will be fast. Some of these circumvention scripts use JSON stringify and JSON parse in order to encode and decode the ads data. What the JSON prune snippet does is to patch the JSON parse function in order to remove some of the properties of the object that is being parsed. Here, without any JSON prune snippet filter, we can see that JSON parse doesn't lose any data. On the other hand, by using this JSON prune filter, we can see that the source property of the ads data object was removed during the parsing. Whoa, I think we are keeping our ground at the sandbox. Let's see the last hotspot at the playground. Taking back the spider web, the network. Strip fetch query parameter is the first one. This is a simple fetch call, nothing complicated. The URL has 2 parameters, ads and count. But we want to remove the ads parameter because we saw that sending the request without it retrieves us the response data without any ad information. That's exactly what this snippet does. In the end, the request URL will look like this. We got rid of the ads parameter. Header-based blocking. This one is still in progress. It allows filtering network resources based on header data. Not really a snippet, but this feature is only available in the anti-civil list. It basically adds a header filter option to the filter syntax. Hopefully this feature will be shipped with the next AdBlock Plus major release. Ultimately, what is this all about? We are fighting the good fight, but what for? Our ultimate goal is protecting user choice. Regarding that, there is a very good document called W3C tag Ethical Web Principles talking about user needs. It says, people should be able to render web content as they want. Users should be able to install style sheets, assistive browser extensions, and blockers of unwanted content or scripts or autoplayed videos. Through technologies such as browser extension, people must continue to be able to change web pages according to their needs. User needs. This is the little brother. Thank you very much.